Good morning, everyone. Now, the next topic of the lesson, thermodynamics, is work. This is the next topic. So, before starting this topic, now you all are aware that we are in Unlock 5. So, wear masks properly and focus on your hand hygiene. Wash your hand regularly for 20 seconds, at least for 20 seconds, with the help of the soap and the water, and keep physical distancing from one another. Okay, now let's come to the point. Now the topic is work. The topic is work. So it is work is defined as, that is defined as mode of transfer. Work is defined as mode of transfer of energy. Work is defined as mode of transfer of energy when system and surrounding. Now, what is system? What is surrounding? We all are aware of the system and the surrounding. So, the work is the mode of transfer of energy when a system and surrounding differ in pressure. So when there is a difference in between the pressure of the system and the surrounding, so that time the mode of transfer of energy is known as the work. That time is known as the work, and the transfer takes place till their pressure become equal. The transfer takes place till the pressure become equal. So that mode of transfer of energy is termed as work. So if an object is displaced, displaced means the object change its place or its position through a distance. Suppose that distance is dx. Suppose an object is displaced through a distance, and that distance we consider dx by applying a force, and that force, that is F. Suppose the force is F. So the amount of work done is given by W. W stand for work. So work is equals to, we know very well, force into displacement. The formula for the work is equals to force into displacement. So here force is F and the displacement is designated by dx. So this is the work done, or this is the work when any object is displaced through a distance dx when we applying the force F. So that is, it is the product. So from this definition or from this formula, it is clear that work is the product of two factors. The first is the force and another one is the displacement. These are the two factors. Here force is the intensity factor and the dx, that is the displacement, is the capacity factor. So if the intensity factor, for example, this one is the intensity factor. Force is considered as an intensity factor and displacement is considered as a capacity factor. This is the intensity factor and this one is known as the capacity factor. So if intensity factor is pressure and capacity factor is volume, if for example the intensity factor is in place of the force, it is pressure is intensity factor. Let us assume if pressure is intensity factor and volume is capacity factor. So the work is called mechanical work. At that time, the work is called mechanical work or pressure volume work. That is P. P stand for pressure, V stand for volume and work. If the intensity factor is pressure and the capacity factor is volume, at that time the work is said to be pressure volume work, designated by PV work, or it is called mechanical work. It is called mechanical work. So work done is a path function, not a state function. Work done is a path function. It is a path function. And what are the path functions? Path functions are those which depends on the path followed. Path functions are those which depends upon the path followed. So work done is a path function. It is not a state function, means which depends upon the path followed. So work done on the system. So now work done on the system. Work done on the system increases the energy of the system. Work done on the system. If we have done work on the system, it increases the energy. It increases the energy of the system and is taken as positive. This is the first factor. If work done on the system, if we have done the work on system, so it increases the energy of the system and it is taken as positive. So here in case work done on the system means is equal to positive, while the second factor is work done by the system. This is work done on the system. This one is the work done by the system is taken as negative. So from these two statements, we have a conclusion, and that conclusion is work done by the system, and the second one is work done on the system. We have two statements, we have two conclusions. Work done by the system, it is negative. it is negative. And second one is work done on the system, that is work done on the system is equal to positive. So we get these two conclusions from the basis of above statement, or there is another method to define this one, and that, or another way to define, another words to define this is if system loses energy, if system loses energy, if system loses energy, work is done by the system. Here in this case the energy is lost, and if it gains energy, if it gains energy, this statement, if it gains energy, because here the energy is increased, so if it gains energy, so work is done on the system, work is done on the system. So we can define the work either by this one or either by these type of statement. So basically the work is the mode of transfer of energy when the system and the surrounding, we know what is a system, the part of the universe which is under observation is called system, and the part outside the system is known as the surrounding, or the remaining part of the universe is called the surrounding. So if the work is the mode of transfer of energy when in between the system and the surrounding, when both the system and the surrounding have difference in their pressure, they both exist in the different pressure level, and the mode and the transfer of energy takes place till their pressure becomes equal, till their pressure become equal, that is known as the work. Now our next topic is mechanical work done by a system. Mechanical work done by a system. Now for that, now in the topic of the mechanical work done by a system, now look at here, this is a cylinder, this one is a cylinder, and this cylinder is having a 1 mole of an ideal gas, means we have kept the 1 mole of ideal gas inside this cylinder, and this have you seen this one? So this is a piston, and this cylinder is having a piston, and this piston is a frictionless piston. This piston is a frictionless piston. Now let us consider the total volume. The total volume is the Vt, and the pressure of the gas is P. Let us consider the pressure inside, pressure of this gas is P, and Vt is the total volume. That one is the total volume. Now what we have do, we have applied a pressure. We have applied an external pressure in this piston, and as we apply the external pressure in this piston, so now the condition becomes like this. Now we have applied the pressure, so this piston is shifted here from this direction to here. Now P expansion is the pressure, it is the external pressure. Here P Ex is written, so P external This is the external pressure which we applied on the piston, and now the position of the piston is shifted from this direction to this direction. So if a P external is the external pressure, this one is the external pressure, and if this pressure is greater than the original pressure which is exerted by the gas which is present here, so the piston moves inward because this pressure is higher in comparison to the pressure which is present inside the cylinder. So the piston moves inside, this piston moves inward until the pressure of the gas become equal to the external pressure, till the pressure of the gas becomes equal to the external pressure. Now come to the main part, that is VT or VI. Suppose VI or VT, it is the total volume and P is the pressure. P is the pressure of the gas. Which gas? Which is present inside the cylinder. Now I have already discussed that if we applied the external pressure, that is P external, if we applied the external pressure, so the position of the piston changes or the piston moves to inward direction, and it means, and when the pressure moves inward direction, the pressure move inward direction when P external is greater than P. When P external is greater than P, so definitely piston moves to inward. Piston moves to inward, and till the pressure of the gas is P. Pressure of the gas is P becomes equal to the external pressure. The piston moves inward till the pressure of the gas equal to the external pressure. So this condition can be achieved by two ways. This condition can be achieved by two ways. The first way is, it is achieved in a single step. It is achieved in a single step, and if it is achieved in a single step, means it is a irreversible process. This is a irreversible process. So let final volume of the gas, let final volume may be VF. VF stand for the final volume, and if the change is carried out in a single step, and suppose during compression the piston moves a distance is L. And what is L? L is the distance which is which the piston move. L is the distance which the piston moves when we compress the piston, and area of cross section of the piston is A. Area, that is area is equal to A. Area is equal to A. So volume, then volume change is equal to L into A. Volume change is equal to L into A, and that is delta V. Change in volume is delta V. I have already told you, we show the change by two symbol. One is the delta and another one is the d, small d. And what is the meaning of delta V? That is the change, means final volume minus initial volume. Vf is the final volume, Vi is the initial volume, and that is the change. That is the change in the volume. We know that pressure is equals to force upon area. Pressure is equal to, this is the formula for the pressure. Pressure is equal to force upon area, and therefore force on the piston, force on the piston is equal to pressure, that is P external multiply area. Now we have changed the formula according to our need. Force is equal to pressure multiply area. If W is the work done on the system by the movement of the piston, then W is equal to force into distance, that is force into distance, that is P expansion A and L, that is P for the value of the force is P external, A and L is the distance which we have already discussed here, that is distance traveled by the piston is L. So work is equal to force into distance or force into displacement, that is P external A L, and that is P external delta V is equal to minus P external delta, or W is equal to P external, and what is delta V? That is Vf minus Vi. So this is the first step.